Hello and welcome to a new episode of GDA Conversations brought to you Gulf Downstream Association. As you know, we have been conducting this series ever since the pandemic started because we wanted to keep contact with the industry and industry players. And during this series, we have had many dialogues and discussions with the industry leaders. Today is our new episode number 16. And today we are going to talk about refinery margin. As you know, friends, refinery margin has been severely hit in the recent years, especially the last pandemic year of 2020. It had even gone down to the negative margin for some of the refiners. As you know, many refineries in the West have even closed because they could not cope with the market pressure. So refinery margin is very much on the minds of every refiner. How can we improve this margin? That is the topic of today. And we have a panel of 4 esteemed experts from McKinsey Company to throw their thoughts and tell us how can we improve the margin of our refinery by $1 per barrel. So our first is Vinay Chandran. He is an expert partner in digital practice. He helps the clients in delivering IR4 transformation, and he has been active for the last 13 plus years in different industries, including refineries. And he is a computer engineer by education. Our second speaker is Vikas Upadhyay. He is an expert associate partner in oil and gas practice, and he is a specialist in operations and digital transformation. He leads advanced analytics for refineries and petrochemicals in the Middle East, and he is a statistician by education. Third speaker is Pawan Mundra. Pawan is an expert associate partner in the global energy and materials practice. He co-leads DNA in refining in Asia, which is end-to-end digital and advanced analytics transformation. He has 15 plus years of experience in the refining industry, and he is a chemical engineer. And our last but not the least speaker is Thomas Hansman. He is a partner and he leads manufacturing, supply chain, and operational excellence programs in Southeast Asia. He is a core member in the Digital Capability Center at Singapore. He is also active in energy, chemical sector, especially focusing on oil and gas and power. And he has double masters in quantum mechanics and management science. We are truly honored with the presence of these 4 speakers, and we truly believe that today we are going to give a lot of insights into this topic of digitalization and how this digitalization can help us improve our refinery margin. So with that, I hand over to the lead presenter, Vinay, to take over and lead the whole presentation.
Thank you, Raj, for your kind words. And on behalf of McKinsey, we are very glad to be part of this session and looking forward to an interactive discussion. As Raj said, this trend of digitization is gaining a lot of pace across industries as well as oil and gas. Today, as we look at the quest for $1 a barrel, we will focus our discussion on a few areas, specifically 3. one on applying artificial intelligence within your manufacturing domain to drive yield, throughput, and energy improvements. The second area we'll also focus on is around how do you think of digitization across the supply chain and how do you drive price realization on that. So we'll focus on that element also. And the last is around predictive maintenance and how do you drive savings on those. All of these in totality, we've seen having significant benefit for refineries in driving their digital transformation efforts. But before we go there, wanted to at least spend some time in setting the ground around what does it take to enable a successful digital transformation. And my colleague has actually put a link down on the chat window, which we would request that you log into and answer this question around what is required as you think of a successful digital transformation. We have given you three options. The one being around a technology-led transformation, where institutions have looked at technological solutions to drive impact on their digital agenda. The second is around an organizational transformation. And here specifically what we mean by that is building capabilities within your organization to drive digital programs, capabilities such as artificial intelligence through data scientists, data platforms or big data through data engineers. So that's the second piece. The third is around the business model transformation, where we've seen clients look at various business processes and trying to apply digital to re-engineer them and reinvent them. Please log onto the link that we've highlighted below, and please give us your view on which one is most important as you think of driving a sustainable digital transformation. Obviously, there's a fourth option, which is all of the above. Thank you for the responses. As we see, the majority of you have selected all of the above. It's interesting to see also there's at least 20% of the colleagues here on this call where technology transformation by itself, as well as org transformation by itself, are also avenues that we've explored. When we look at some of the hundreds of digital transformations that we've actually led and researched, we see that the key enablement required to sustain a digital transformation is along these three dimensions. All of these are important, and we'll talk about those as we go through today's agenda, and why it's important and why some institutions have struggled. And as you think of that struggle, what we'd like you to do is also engage us further in another survey, which is around what challenges are you facing as you look to scale your digital transformation. We'll send you a link again, which allows you to do that. And please go on to that link and you can then enter your comments free flow into that window, and we can at least use that to understand the overall perspective of the group. So as you see, there are a few elements here which we'll be actually talking about in the next slide, but let me just pause on this a bit. A lot of you have identified a few themes that relate to the challenges you're facing to scale your digital transformation. One is around strategy, and I think I'll talk about that. So on change management, I believe is what those colleagues are referring to, as well as understanding what it takes and what we mean by digital to a large extent. If I look at all the other words that have been entered, I can see a theme around culture and change management that resonates across all the different types of words that have been used. There's also a theme around technology, capital, value, delivered, etc. If we think of all of these points that you raised, I'd like to maybe summarize them into 7 challenges that we see institutions face and refineries in particular face. Those 7 challenges relate to, one, the lack of awareness on the value being delivered from the management team. They also then relate to a strategic roadmap being clearly identified on where that value is and how do you actually capture that. And we'll talk about this in terms of how do you get to the dollar a barrel improvement. The third challenge that we've also seen institutional refineries face is the potential use cases that you define, that you actually roll out as pilots, have not had a thorough scrubbing in terms of the business value and what they deliver. And typically this is because they are more technology led versus use case and business backed. And some of the examples that we show you today stem from where is the value, and then how do you actually drive that through the enablement of digital and analytics. But what that also requires is capabilities, specifically digital capabilities around data science, data engineering, etc., which I think was also mentioned in the word cloud that we saw earlier. And then you had this big block in the center on the side, which was around change, the change management framework, which we also resonate 100% with. There are also comments around data platforms. And specifically in the region, what we find is, given the sovereignty rules that each of the refineries have in the location that they are, the ability to scale data and actually consume terabytes of data is limited by the architecture that they have. And so we can talk about some of the tools that we've seen refineries implement to overcome that, as well as linked to that, obviously, the IT infrastructure in terms of scaling and actually driving it. If I think of all of these challenges, refineries are in particular affected as they think of driving value through digitization and what it takes. And when you think of what it takes, it is these 3 elements that I was mentioning. So if we go to the slide somehow around the 3 recipes, that'll be very helpful. Thank you. The sustainable value capture is around the business transformation, the organization transformation, and the technology transformation. But more specifically, it lends itself to 8 practices. On the business transformation, there are 2 core practices that we see. First one is around the strategic roadmap. What are the use cases that deliver? And we'll talk about specifically what use cases do we believe that can deliver the US $1 a barrel optimization. And they are then linked to a new delivery model, which we call an agile delivery model, where process engineers, data scientists, data engineers, and the commercial teams work together to actually unlock that value. But to unlock that value, you need a certain set of enablers. One being around the technology side, which composes both a data platform, but cybersecurity practices, as well as an infrastructure to deliver those capabilities at scale for not just one use case, but hundreds of use cases that you would deploy across your refinery. Now, while you have an enabler around technology, another core enabler is around the organization. I think, and when we saw the survey, 70+% of you mentioned that all 3 are important. As you look at organizations specifically, the talent around this new breed of digital specialists that refineries need to attract, as well as how do you change the way of working in the refinery, the SNOPs, etc., to allow for this agile delivery model to work. And then the third is the element around exciting and engaging the whole organization. And I saw some elements in the word cloud that mentioned how do you actually get the confusion around digital, and actually how do you drive that transparency to focus the organization towards the $1 a barrel. What we'll now talk about is where do we see that $1 barrel across the value chain, and then specifically what use cases are can be deployed in order to go there. Now, when you think of the energy sector, and you think of the energy sector versus and refineries versus all of the other sectors that we have, we see we're at a certain level of maturity, and we are, if you look at the scale, below average. And there's a few reasons that we've talked about earlier on this. But when you do succeed, what we do see is that those digital leaders are able to drive significant improvement in their EBITDA, in this case, 4x, as well as a return to their shareholders. And that's the profile of refineries that have been able to achieve the $1 a barrel in terms of refinery margin improvement. They're able to take all the elements that I talked about in terms of the business transformation, the org transformation, the technology transformation, and outpace their industry, outpace the entire sector in delivering those returns. And those returns are in a few domains. Though those improvements are in the refinery in terms of the maintenance function, in terms of the manufacturing function, as well as in the broader support functions. The way we think about it is what we call a digital refinery of the future, which delivers around 30 to 40% improvement in your operations, 20 to 30% reduction in your maintenance costs, as well as driving your overall operations to first quartile or second quartile Solomon benchmark results. This is through a range of use cases. And what we've tried to highlight on the left-hand side is some examples of them. They could be using VR and AR techniques to drive on-field monitoring. It could be AI and machine learning models that help you improve your forecasting mechanisms. It could be machine learning models also in your specific units to drive yield improvement, as well as a broad IoT stack that connects all of your sensor data, all of your historian and system data together in one location to build those models that I just talked about in a scalable and effective manner. And that digital refinery of the future will have new talent. It'll also have new way of working, as well as this infrastructure that I talked about. Now, when you think of this digital refinery of the future, and as you think of clients that we've supported to deliver this, they've achieved that across a few domains. One is, as I was mentioning, production. The second is maintenance. The third is procurement and supply chain. And the last is around marketing and sales and other shared functions. If you look at where the value is around that $1 a barrel, it's along these dimensions, and the size of the bar charts reflect the size of the value. So there's significant value in production, significant value in maintenance, as well as procurement. Today, as part of our discussion, we'll focus on these three areas to highlight how have refineries actually unlocked the value within the production domain, within the maintenance domain, as well as in the procurement domain. Then, just to make sure we have enough time to actually discuss these, what we'll do is we'll actually move into some of those discussions. But before that, just to highlight how does actually that look like from an overall perspective. If you just go to the next slide that we have. These are the use cases that we have across all of the domains. And today we'll focus on the ones that are highlighted, which is how do you drive margin improvement within your production domain? How do you drive both predictive and prescriptive maintenance techniques in your maintenance area? And how do you use AI for procurement spend analytics? And we'll address some of the questions that are coming up in the chat window as we go through each of these sections, if that's okay with the broader group. But let me first hand it over then to Vikas, who can actually talk about the first domain. Thank you.
Good afternoon, everyone. I will spend a few minutes on AI in margin improvement within production domain. So to do any margin improvement in within operation domain, first I would like to introduce this solution we have, which is Optimus AI. Yeah. This is an AI-driven model and a set of tools that helps in optimizing the margin within the refining units. Yeah, both within the unit as well as cross units. So it could be FCC or hydrocracker reformer, but also across the units, like in blending operations, fuel oil optimization of viscosity and sulfur, or it is RON for gasoline blending. So it can help in quick decision making within hours as well. So now, as we move along, where does this sit? So this Optimus AI in refining, that would sit in between your APC kinetic models and the PIMS or any of the LP model you're using. So this seamlessly fits into all the all the all the refining suite we have in the refineries, and helps APC to further optimize the unit by providing set points. You know? And these are data-driven AI machine learning models, which is taking data, constant feed data from the data historian, running the optimization whenever the operator wishes to run, and then providing set points recommendation to the APC. So that's why it just sits before the APC and seamlessly works with the APC. I'll go into more details later when in the questions maybe and how exactly it will work. But I want to quickly show you the demo as well, so that makes it more clear. So, and we have a proprietary kind of approach to develop these AI models to further optimize the unit performance. It can take inputs, and we define those inputs. It could be from data historian Pi servers, or your LIMS lab results, or even paper logs at times, ERP systems, and so on. Yeah. And then there is a set of codes written in Python and very complex algorithms that can actually replicate what's happening in the refinery, the non-linear relationships, and then finally give a results which an operator and a supervisor and others can easily understand. It's very clear recommendation on set points that a control engineer can actually go ahead and change in the APC. And for the management, they get a full view of what's happening in my unit at the profit level. So a very quick estimate of where are my profits from a particular unit or refinery as a whole, and what are the improvement potential, and how can I quickly move there. So it provides all of those. So I'll quickly show a demo here that will make it more clearer, and then of course we'll discuss in depth when we discuss the in question session. So I will start with a dashboard through which we will run the optimization model, which is sitting behind this dashboard. And what you see right now, this is only the front end. Behind this is the entire Optimus AI model, which is the AI model that is running behind the scenes and giving simple inputs and in a simple dashboard for both the management as well as the operator. So what you're currently looking at is the management view, yeah, wherein in a summary, what we can get is what are the refining margins, yeah, what are the operating profit and how it has evolved over time. And again, there are options to see past 1 week or past 1 month. By the way, data here is masked, so it's dummy data to avoid any confidentiality. So the numbers are not any specific numbers, it's all dummy. Yeah? What are the product yields before and also after optimization? So both the views, how much money I will be making from current to optimized, and then other metrics as well. What is my uptime, feed intake for the unit, inventory level, supply chain information, even HSE information. So all these can be visualized, and the numbers that you see on the product yield and the profits, behind this there is an optimization model that is actually running behind the scenes and providing the summary over here. Then can also deep dive on a particular unit. Again, similar view for that a particular unit, for example, FCC, and similarly for CDU, VDU, and other units you can have. And of course, it can be customized for specific units, depending on the refinery, yeah, and its configuration. I will now move to the operator view. So how does the operator will use day to day? Yeah, this. So first, the operator comes in, logs in, and says, why don't I set up an optimization? Maybe that's for FCC. Have I set this optimization earlier? Is this the first time I'm setting this optimization? No, I've set this earlier. So I need to put a date and time. So let me select maybe 3, and I say confirm. Now it asks whether I have done this previously. The answer is yes, I implemented, but maybe partially. I confirm that. Now, to do any optimization, AI-enabled optimization and implementation, you need to be confirmed saying, okay, is my unit stable? Before I start making changes, my unit has to be stable, and stability can be defined through some parameters. Yeah, for example, the feed rate, the feed temperature, the reactor temperature, main column temperature, and we look at last 6 hours of data and see, okay, it is stable within plus minus 5% deviation, for example. And we say, yes, I can set up my optimization. I come to the optimization. I have set of variables very clearly defined that will actually change, which is, for example, main column temperature, combined feed, reactor outlet temperature, and so on. Yeah? So there's a min and a max value within which the optimization can optimize. Yeah, and this is defined based on the refinery unit and the conditions prevailing at that time. Similarly, on the constraints, whether the wet gas compressor, how much can it move, or the gasoline T90 or the diesel T90, and so on, right? So all those can be defined to set up to as a min and max value by the operator to run. And finally, the prices. Now these prices can be contractual prices, or it could be linked to market prices. So both options are there. And once I've set up the prices, then the model will run to provide me inputs. Yeah? So let me see the output here. So what the model is suggesting now to the operator, you know what, to maximize the profit, you need to change your reactor outlet temperature from 500 to 510, and the combined feed temperature by 5 degrees. Similarly, main column by 5 degrees, and so on. Again, these are dummy numbers, but this is what exactly the set of recommendation an operator would get. And the variable also changes depending on the refinery and the unit. So the AI model will actually tell which variables are the most critical ones. Yeah? And mostly these are manipulatable variables. And how much output do you expect? Yeah? So if I like the recommendation and the target setting, I will say accept the recommendation. This gives me a summary of where are my profits. So at the last time I was at 1732. One day later, I'm a bit higher, and now I'm even higher. So it will track the whole profit as we go along. So the operator can actually see that whatever changes that operator is doing is actually contributing higher and higher profits for the company, for the refinery. Yeah. In addition to that, there are some monitoring tabs. I will not go through the details, but actually the operator can monitor all the set points where it is. So the blue is where we are, red is the target, and the yellow is actually, this is how I'm moving towards the target. And again, live, you can the operator can monitor. And similarly, the operator can also monitor the constraints defined in the dashboard. And finally, of course, the output, how much profit I'm making, and so on. Yeah. So this is basically kind of the full optimization that runs in the Optimus AI solution. In the process, what it would do is it is taking your refinery configuration, optimizing the profit function, and the profit function is defined like for the unit or for the refinery. It's both, depending on the use case, and then very clear set points like you saw will be provided to the operator on specific inputs, main column temperature or reactor outlet and so on. And also, in addition to that, if the operator makes those changes, how much additional profit am I generating for the unit and as well as for the refinery? Yeah? And these AI models are data driven, but along with it, the process engineering expertise also goes along with it. Yeah? So first you visualize the whole data and see how the data is behaving in the past, and then build predictive models, machine learning models, so that it can replicate the behavior of the plant. Yeah? So if it's FCC, it's kind of similar to digital twin with not the visualization, but from the data perspective. Yeah, replicating the unit behavior, and this models the complex nonlinear relationship. Yeah, because these are machine learning models now. And then finally optimizing and giving very clear set points to the operators. So this is the whole process. Yeah. I'll take a pause here because we need to move, given the time, we need to move to the next section, and happy to take questions at the end.
Okay, so in the next section, as introduced, we will be discussing about predictive maintenance, right? And it's no secret, of course, that for oil and gas company, refineries, petrochemical companies, minimizing downtime is one of the key value creation opportunities, right? And here we will be talking about the proprietary solution from McKinsey that is called Providence. Now, of course, I'm sure you have been exposed and you have seen many different solutions in the market. And what we will talk about today, this Providence, of course, covers all the usual features that you will see in the market. But in addition, we will also cover three elements that are quite unique, right? So the first thing is, here we talk about prescriptive maintenance. So we don't just provide alerts, but we also tell the maintenance team, the operations team, what is the root cause of the issue, and therefore what they should be doing, right? So this is what we call prescriptive. The second thing you'll see, we have a pretty intuitive user experience, user interface design, and journeys that have been developed with actual maintenance and operations teams. So this is typically something that is very user-friendly for the teams, right? And the last thing we'll talk about is how this solution integrates with various analytic solutions, right? So we can use any types of analytic solutions from McKinsey, analytic solutions from each and every company, or analytic solutions from various potential vendors, right? Now we thought, instead of talking through slides, right? Again, we will be doing a demo, right? So I'll be taking you through this demo for Providence, right? The first thing, of course, Providence is a web-based solution, right? It can be hosted on the cloud. It can also be hosted on premise, right? Depending on the preferences of each organization. And of course, the first thing that you would do is you would want to log into the solution. Depending on who you are, whether you're part of the HQ, you're part of the individual refinery, you're an engineer, you will have a different user journey, right? Different things that you want to look at. So if I take, for example, here as an engineer, and you want to log in as an engineer, right? The first thing that you will access as an engineer will be your specific site, right? So you will be seeing your different units, your different equipment. If you are part of the management, for instance, if you're in HQ, your journey will start at the overall company level, right? So you'll be able to see what are all the different sites, and is there any site that is facing a challenge or has a risk of downtime, right? So in this case, if you were to log in as management, you would see that, you know, across all your assets, all the equipments are healthy. And then in this specific site in Dubai, that's where it looks like there might be some downtime coming up, right? So you can see one equipment that has alerts, you can see 4 equipment that have anomalies, right? So you would use these to triangulate and start going into individual sites, right? So here again on the left, you would get a sense of which of your process units might be failing. So here you can see, for instance, in green, the platformer, the hydrotreater, the power units, everything looks healthy, it's green, right? On the other side, if you look at polymerization, the atmospheric hydrotreater, it looks like there are anomalies, so equipment that have some anomalies there. And in the RCC, there is an alert pending, right? And then again, as the maintenance team or reliability engineer, right, you will want to go and understand for each of these equipment what is happening, right? So here, for instance, you will scroll through your equipment. You can see various equipment that are perfectly healthy. And then, for instance, this main air blower has an alert. This feed pump reactor has an anomaly, right? So naturally, you will then want to go to the next level of detail. So if I take, for instance, this pump, right? We have two main elements that we will be looking at for this pump, right? The top portion that we have here in yellow is what we call the predictive portion, the predictive analytics, right? So this is the one that is saying there is an abnormality, something unusual. And you can see there's a probability of 51% that this pump will fail. Importantly, also the analytics tells you which of the sensors are contributing to the potential anomaly, right? And in this case, you can see that this radial end vibration is the main contributor to the anomaly, right? So 78% of the issue is coming from this sensor. As an engineer, again, if you want, you can go and you can explore the data, right? So you can see exactly what is happening from your historian for that specific sensors, for any sensor, so you can understand the issue in more detail. So all this is the predictive analytics. And then there is an additional layer below that we call the prescriptive analytics, right? So here what we have done is we have worked with various OEMs, so equipment manufacturers, right? And we have developed exhaustive failure libraries, right? So essentially we discussed and said, what are all the reasons why this specific pump could be failing, right? In this case, we identified around 90 different potential failure modes. And for each of the failure modes, we also identified what are the sensors that will get triggered if these failures were to happen, right? And what the analytics then is doing a bit of a reverse engineering, right? The analytics is saying, okay, now if this radial end vibration is having an abnormal signal, which of the failure modes is most likely to lead to this, right? And the analytics is then prioritizing which failure modes in the library are most likely to lead to this, right? Now, what we have observed from our experience is around 50% of the anomalies are actually coming from sensors that are having issues, right? So the first recommendation is always to go and check the sensors. But beyond this, if the sensors are working, right, you can see the first priority to check, second priority to check. And this gives an initial guidance to the reliability team, the maintenance team on what to do, right? So they can see the potential root cause. For instance, here, they will be able to see, okay, there's maybe insufficient lubrication, right? So they'll be doing a lubrication inspection. And they use all this. If they don't find the potential issue, they have a full exhaustive library of all the potential failure modes that could occur for this pump. And this is also something that learns over time, right? So if over time, they add new failure modes that they identify, this library keeps enriching as well, right? The typical last step in this is to then share this to operationalize it with the maintenance and operations team, right? So all the different analysis will be automatically populated into the mail system, right? And it can also be linked to text message, it can be linked to WhatsApp, right? And then this can be automatically shared, right? So all the analyses are pre-populated, the data sensor signals, what is the potential failure mode, what's the probability of each of the different sensors, right? Individual sensor data, and they can automatically be shared with the team, right? Which accelerates, again, the intervention. So this is a bit of an end-to-end view on how the user journey looks like, right? Of course, there are many additional features. People can go back in time, right? So there is a time machine for people to go back and understand past failures if they want to understand what happened, right? So all this is available here. And this is, of course, very easy to tailor to each and every company, right? So very quick to do. Typically in something like 8 weeks, we're able to design the system and we're able to launch it on an initial pilot of 10 critical equipment. So again, in the interest of time, I'll pause here. If we can move to the next section, and at the end, of course, happy to take questions across sections.
Thank you, Thomas. We'll do this section quite quickly. And this is all related to how do you use artificial intelligence to drive savings as you look at your procurement function, as you look at your spend in the procurement function. If you just move to the next slide, the whole premise is around data that's being captured by various systems in various formats, structured and unstructured, and the ability of actually, the value of actually bringing that data together in one cohesive manner. So if you think of how procurement functions work, is there's a typically an ERP system or a Reba, for example, system that actually captures a lot of your spend information. That is structured in terms of your suppliers, who they are, the POs, etc. However, where the art of the possible is if you could actually then take that information further, or by actually looking at your invoices, by looking at the various invoices that you have across your group, across your entire, let's say, supplier base, and bringing that information together to drive a full and accurate transparency against your suppliers, against what type of material you spend, there's significant value to be captured. And what we've seen is when we work with refineries on this, there is a lot of information that can be brought together, especially from the unstructured side. And as you start building it together, you realize that for the same type of equipment that you have, there is different suppliers that have been providing that equipment at different prices, which makes sense, but also the same supplier providing the same equipment at different prices for different reasons potentially. And therefore the value of these such methods, for example, artificial intelligence methods, is around building a strategy around how do you actually, for those various supplier related discrepancies, as well as for more broadly category oriented strategies, what's the opportunity to unlock savings? And we've seen even refineries in the region, by applying these techniques, extract more than 15% savings across some of their major spend categories. As you think of all of these things that we mentioned today, there is an overall roadmap and approach that you would take to capture that value of $1 a barrel. What we highlight here is a roadmap that has a few principles that it's based on. One is ensuring that value is delivered very early on. And therefore, as you think of your digital transformation, it's critical that value is unlocked very quickly to excite the organization, as well as to prove these new concepts across the entire organization. The second is, the principle is around delivering all of these transformations in agile sprints. And what we mean by agile sprints is, in 3 to 4 months, delivering a particular mini transformation that combines both the business angle, the technology angle, and the organizational angle to unlock value. It could be unlocking value in your production domain, it could be unlocking value in the maintenance domain, or the other functions that we talked about. The third principle that is important is to think of this as a journey that actually you will continuously evolve over a period of time. This roadmap may hold true, maybe define the beginning, but will need to continuously evolve over a period of time. And therefore, what we see companies do is they map out their journey for the first year, and then over continuous iterations, evolve that as they go by. Let me pause there now and actually come back to the broader point that I was trying to mention is, let's actually open the floor to questions that we have.
Thank you very much, Vinay, Thomas, Vikas, and Pawan. It was a great tour of how you can help the refiners to improve their margin through so many tools which you have developed. Let me first share with you my understanding of what I have learned. One thing is that these artificial intelligence, machine learning, and all of this is all going to give you a deeper insight, and ultimately it helps you to take a better decision. So humans cannot be replaced by the machine. all it does is it helps you take better decision, get better insight. That's my observation. And probably it's a myth lots of people carry that future of refinery will be humanless. Uh, it may be less human, but humanless, I doubt. The second part is that when you want to go on this road and try to do the digitalization, we need to be careful in making the investment and justifying the investment through the use case scenarios, and also take the low hanging fruits first, as you said, to realize the benefits early across the organization to showcase the benefits of these technologies. Am I right, my observations and understanding, Vinay?
Yes, thank you, Raj. You've hit the key points very well. I think for sure, let me just maybe just elaborate on some of the points you mentioned. For sure, the way we think of artificial intelligence and more broadly, any of the digital tools and techniques, it is about enabling the frontline team to make better decisions, but it also is providing all the facts required so that they can make those better decisions. And so that's one element, but it's also empowering them so that they can make the best decisions. So there's an element of capability building, there's an element of helping unlock the way they work. So these are 3 or 4 pieces that we also see very important. So we don't see humans going away at all in the future. It's all about making them much more effective and efficient.
So you mentioned about the capabilities. So what are those capabilities which are absolutely essential to implement and sustain such a transformation?
So let me start and then I'll hand it over to my colleagues also. There are 3, 4 capabilities that I think are very critical. One is, I think, the most obvious, but people would anchor on, which is around the digital capabilities. And what we mean by digital capabilities would be the domains of the new disciplines of data engineering, data science, etc. How do you build these models, these AI models that we talk about? That's one capability, which refineries should think about as they look to actually deploy some of these solutions. But the second capability is that is important is what we call translators, at least in the firm. And what these translators are is essentially upskilling your current existing process engineers to be able to work with these data scientists to identify those optimal operating conditions. So for example, a data scientist can build a very fancy machine learning model to optimize an FCC unit or any cracker for that matter. But that model may not be as helpful unless you have a process engineer who understands how that unit is functioning and translating some of the insights of the model to actual practical recommendations on what set points need to be changed for that FCC unit. So there's a translator capability that needs to be built in refineries. The third capability that's important is what we call design competence. So, as you look at building these solutions, what you want to make sure is that the interface, for example, Thomas was showing this beautiful interface of a prescriptive maintenance model. But the interface of how operators react or engage to these solutions and the way they make decisions on that's an important capability. So what we have is thinking around the design of those solutions, the way that operators would interact, and the journey along the chain. So there's this third capability that we think as operators look to actually broaden the solution kit, that's a competency that's relevant. And the fourth one, maybe the most important one, is around change management and culture change. How do you actually take all of this new way of working and scale it across the organization? So those are the 4 things. I'll let maybe Thomas and Vikas also elaborate.
Thanks, Vinay. I think you covered the key capabilities, almost all of it. When I see my clients, they're asking 3 questions in there. I mean, what are these capabilities? Like we answered, but how many people do we need to get started? Yeah, my digital team, or what is the talent mix required? So data engineers, data scientists, and so on. That Vinay just answered. Finally, the question is, where do I source them from? Yeah? What these are new capabilities, right? Whether I have it in-house, I upskill my own people, versus how much I need to hire, yeah, from outside. So for example, data scientists is typically you won't have in-house, yeah, versus the translator role, which is very critical. Those are the process engineers, the controls engineers, and so on. Yeah, so you have it in-house. These are few of the questions that comes when you start thinking about talent and capabilities to make it sustainable in the long term. Yeah.
That's great. Vikas, if I can, sorry, Thomas, do you want to throw your thoughts on the same question? Yep.
I think already well responded by Veena and Vikash. We can move to the next question.
Okay. Vikas, you mentioned about Optimus fitting into existing refineries seamlessly. Can you little elaborate on that? Do they not need to do anything absolutely to adapt it?
Okay. So there are three key elements here. One is the technology part. Another, and when you think about the circle that we showed, business transformation, organization, and technology. Yeah. So this all three comes together when you implement it and make it sustainable. So from the business perspective, using this Optimus AI and the set points that are provided to the operators and the controls engineers, etc. So they need to implement so that there is an adoption there. Yeah. How do you put in these set points inside the APC? Yeah? So that's one. The second part is the technology. There are two ways. One is it could be disconnected from the APC in the sense it's a advisory. You still do it manually in the set points you need to set, or you go advanced and link it and say this is a closed loop for me now. Yeah. So I trust the AI model enough that I can make it a closed loop now, which typically takes a bit of time when you build the confidence before going for the closed loop. Yeah. And then finally the organization which comes along with it, so which is the change management, right, on how you adopt this going forward and the decision being made on this. In addition to that, there are other refinery solutions, right, or refinery tools like scheduling models, like LP models, not only APC but others. So this fits in nicely with those tools as well. It takes inputs from those tools wherever it is available, and then provide recommendation to the APC. Pawan, you would like to add anything here?
No, because you have fairly covered, Raj. To be very frank, all these AI modules can be built on open source technology and can be residing on your cloud platforms or on-prem basis, right? So there's not much of investments out there, and it can be both advisory solutions as well as closed loop solutions, as Vikas mentioned, right? So very easy to implement in terms of implementation, challenges, and I would say once people are confident, it very quickly moves to the closed loops and becomes self-sustaining in nature.
What about the data security? We are talking about clouds, we are talking about algorithms. Who owns the data, and how is the security protected?
So I think so. If in the cloud case, you may ask such questions, but I think so. What people can also do is they can go on-prem, right? So basically, within your own setup, right, you can build these tools. So the data would flow from your process historian to your local computers in your server, and that's where you get the tools and recommendation, right? So it could be, you don't need to go out from your own server. It can be very much located in your local servers also.
Stay away from cloud. Is that what you are saying?
No, not necessary. I'm saying if you're going for cloud, then there are additional checks needed, because I'm just linking it to the previous question, right? In terms of investments and thinking about the scale, ease of implementation. But it is very easy to implement if you even don't want to go on cloud, and because a lot of companies have different scales of operations, right? So people in head office might want to use it for, let's say, Catalyst Live, the same model. The process engineer might want to use it for a different purpose to, let's say, give guidance. the planning may want to use it for different purpose. So if you want to use it, let's say across board, and your company has got different setups, then probably to make it scalable, you may need different levels of servers, right? And people also do it on clouds. But if you want to just start for your, let's say, a frontline operations where it would be an advisory tool to your operations, then it could be very well established there itself in the control room.
Right.
Very similar to APCs or RTOs of the world.
Right. My last question to Thomas. Thomas, you talked about providers and you showed us how it can make some prescriptive prediction on the maintenance of different equipment. Can this algorithm be self-learning? Can they be taught, retaught, so that keep on improving the accuracy? And can the accuracy be 100%?
So the answer on the last question first, on the accuracy, can it be 100%? The answer is definitely no, right? I think in our experience, we can reduce downtime by around 50%. And the reason we cannot decrease by 100%, right? There are multiple factors. The first factor is that there is a set of downtime events that are triggered outside the plant, right? So for instance, if there is a lightning that is hitting your fuel tank, you may end up having downtime, but it is not something you can predict, right? Because there is no sensor on lightning. So there are some events external to your site that you cannot predict. The second reason typically is that the equipment you have are not fully covered with sensors, right? So for instance, you may have a compressor, and on some of the auxiliary equipment of the compressor, you may have no sensor. And so if the failure is triggered by that auxiliary equipment, you will not get any advance notice, right? And the third reason is you have some of the failures, for instance, electronic failures, that are almost instantaneous, right? So when that electronic component fails, you may have downtime and you cannot see it coming ahead of time, right? So again, typically we cannot predict 100% of the failures. Now, when it comes to the analytics, right, this is absolutely self-learning, right? So if I look through the history of predictive maintenance, I think until 5 years ago, a lot of the predictive models were based on equations, were based on what we call first principles, right? So you would have experts that would say, for that specific pump, the threshold is at 250 degrees. And they would have to manually update this as the operating conditions of the equipment change. Now, the models that we see that are best performing today are based on advanced analytics and are not actually using first principles, right? So the way these models work are typically that they first look into the history, right? So for the past few years, they understand what normal operating conditions look like. They also understand what the data looked like before a failure in the past, right? And then these agents are then installed live and they keep learning the new operating conditions, right? So anytime they see data that looks normal, they say the data is normal. Anytime they see data outside the normal operating conditions, they will raise anomalies. And if they recognize failures, they will raise alerts, right? And then as they get feedback, if the operator says this was really a failure, this was really an anomaly, then the models learn again. Right? So they keep learning with new data that is coming in.
Thank you very much. Let me now open the floor for questions from our range of experts from technical committees and guests.
Thank you, Vinay, Vikas, and Thomas. Very, very interesting. So I was just thinking about the various digital modules, whether it is the digitalization transformation, and then you went into the various algorithms you are using. And I was thinking about, you mentioned about the scientist. You'll not find the scientist in every refinery to develop specific algorithms. So what I wondered about is the second question first, whether or not the applications you have, they do have some deep learning whereby they can detect and propose an algorithm based off the previous learning, or your data scientist would, based on every refinery, every context, would develop the right algorithm that will be run using the application.
So let me start with a couple of things. One is the way we've thought about capturing the $1 a barrel optimization, as we said earlier, was linked to the three lenses, right? One is the business, process, technology, and org. So therefore, a lot of the solutions that we've talked about today, or a lot of the use cases rather that we've talked about today, rely on very close interaction with your process engineer to understand the context of that particular unit. For example, a refinery here in the Middle East has a completely different context to a refinery, let's say in North America, Western Europe, as well as Asia. So therefore, what we find is the building of that transformation and those solutions, which are part of the transformation, require a certain set of contextual configuration, if I may want to call it. Now, for example, some of the solutions we talked about are all machine learning models, based models, right? So they look at historical data and they identify patterns, non-linear patterns, multivariate patterns, and they use different types of machine learning techniques to find the right predictive view of building that unit in a digital sense, right? So that digital twin sense is there. But coming to your point, can we extend that further to apply then deep learning models to have which have some component of self-learning ability? We haven't seen that yet, being applied at scale across all refineries. So I think there is an element of first applying first the machine learning, let's say, suite of algorithms in the refineries and actually extracting value. We surely see, yes, if you have at scale refineries across multiple locations, then you have enough data to actually think through some of the deep learning techniques. But we're happy to discuss that further. There's some latest research we've done around genetic algorithms that actually could lead the way there. But let me also hand over to Vikas and the other guys to talk more on this.
Thanks, Vinay. I think you covered all. So still, it's early days, I would say, for machine learning. So I can see refineries evolving over time, and then we move to self-learning and deep learning, right? So short answer is actually we haven't seen any refineries still going there. Yeah, it's still for a bit few years down the line.
One point actually, just realized, it all depends actually on the use case also. So if you think of, because now we were just focusing on the production use case. Now, if you think of outside of production, or if you think of applying this in a different setting, in unstructured environments, where you're looking at images and you're trying to see, for example, flaring, etc. In those contexts, we're using image data and trying to, through image data, build models to figure out how do you optimize certain parts of that production process, right? In those cases, I have seen deep learning models being applied, but that's in very specific use cases where you do need to evolve from structured data to unstructured data. For example, images for flaring would be a case. And there you actually start using different types of cameras and therefore, you have different types of techniques of actually learning from those. So we've seen that.
Yeah, thank you very much. Very, very interesting times, very interesting. I believe this is like the beginning of something even large as we move on and progress and see where AI will get us.
Thank you, Dr. Sadi.
Thank you.
That's true, Dr. Sadi. We are on a starting point of a beautiful journey. Post-COVID, we are on a beautiful journey. Any other question?
My question, Vinay, to you is that you mentioned this whole discussion about getting an improvement or $1 a barrel. So what kind of spend or cost is also, if you can give an idea, also in terms of, say, cents per barrel or whatever it means? That's one. Second, out of, there were three key items out of this $1 a barrel improvement: production, maintenance, and procurement, where production is the major chunk, almost 50%, which is 50 cents to a barrel. And most of the discussion was around Optimus AI, which I believe people who are in the industry, means most of the people are using, whether it is a LP model or a PIMS equivalent, for decades now. So I couldn't really appreciate what additional value this tool really brings when people already know. And just by optimizing the APC will not really get you that margin. Really, what brings you the margin is that what is the demand in the market, what your marketing is giving inputs, whether you need to produce more diesel or gasoline. And also, as you are all experienced enough, people make money by not optimizing the maintenance or optimizing APC. They make money by the crude what you process. So that's only the feedback I wanted to give.
I think, Gurvinder, you've touched on a few points which we do address in the way we actually look at the production domain, all along the lens of what you just mentioned in terms of how do you think of that optimization window and what are the factors that we consider. Maybe Vikas and Pawan can actually elaborate and just.
Yeah, sure. So Gurminder, first, I would like to give a clarity, right? Optimus AI is not a classic PIMS or RPMS kind of LP. Those are single models run on a month average, uh, with fit for a purpose kind of a strategy on crude selection, refinery operating strategy, as well as product mix from the refinery, right? So that's one. So it's a very different thing than what Optimus AI is. Optimus AI is primarily, you're you're doing the same every minute with each and every plant of yours, right? So for example, the strategy for, let's say, FCC was to maximize propylene, right? Now that is what your LP gave, and the same would be translated by a process engineer to the planning to process and process to your operating folks, right? What this model basically does is, with the help of AI and artificial and machine learning tools, this would basically give them that to achieve this at every moment, what is the different parameters need to be kept in the plant, considering the profit per hour maximization kind of a value lever, but also what is changing in the feed side, right? So if, let's say, your feed changes from X amount of UOPK to Y UOPK 11.8 to, let's say, 12, then what is the things which you need to change in the plant, right? So this is something which is online, reading your data, understanding your feed conditions and playing with your parameters to achieve that same goal every minute, right? So that is one big difference between what Optimus AI is and what PIMS is, right?
Thanks, Pawan. I would like to add here, and I want to take us back to the three circles. Yeah. So Optimus AI is not a tool. Yeah, it's a tool plus the other two circles as well. This is not only technology, but also the business as well as organization changes. And what Gurvinder, you said that marketing interaction with marketing will bring value. Completely agree, 100%. Optimus, what it does, and when I showed the demo, it takes prices. It depends on the spreads in the market. Now, whether we want to do it real time or a weekly average, that's depending on the contracts. Yeah, and it takes those prices. So it's taking that marketing intelligence through the prices and the spreads, and then optimizing the profits, as well as on the other side, it takes the operating condition changes that happens in the refinery life. Yeah? So all those combined, then it maximizes the profit. And now it tells APC, now you go and implement this in a control manner. APC never optimizes things. APC controls things. Yeah. So this Optimus or any RTO for that matter, right? So this is more AI enabled. These are actually telling APC how to operate best, yeah, to maximize the profits. So the objective function is always profit.
So you mentioned about the future or digital refinery of the future. I was rather interested in more about refinery of the future, because the refinery of the future would not be like this. So people, if you think about now, are more focused what their refinery in the future will look like rather than focusing on digitalizing the refinery. And that's why means there is no surprise. All the big projects, not only in Middle East, in large parts of the other parts of the world, are really stalled, because the big question is what the refinery of the future will look like, producing sustainable fuels, processing not only crude, but some other kind of feeds. Also, what about decarbonization in the refinery? What about the green and blue hydrogen production? So I think those are bigger concerns, in my view, for the refineries rather than digitalization.
Very fair points, Gurminder. I think these are very important points that we are looking at in the broader practice, our refining and oil and gas practice. And in fact, we do plan to share some of our thoughts as it relates to some of those thought pieces you've mentioned, which is, sustainability, etc. And so hopefully, when we have some of these follow-on sessions, we can talk about those in detail, specifically around some of the points that you mentioned. They're very true and very, very pertinent to the sector now on how you think of the broader agenda.
And one last point, Gurmeet, to your CapEx question also you had. So that comes that if you think about it, the refinery of future and the CapEx stalled. That's why we believe, and which is given the strain, the margin, the strain on the margin, we expect this to continue a bit. That's where these AI models and optimization model helps, because these are almost low to no CapEx, right? Because you are just extracting more of your current assets instead of doing a build something new. You build new capabilities, not assets per se, except for maybe in maintenance you might have to spend a bit, but majority of this comes with almost negligible to very low capex.
Yeah, I mean, it's what we have seen rather in one of the themes which we were leading in our committee. We did a survey for why people are hesitant in the refineries doing the digital implementation. And what I believe the results, what we got, there is a lot of people, everyone talks about it, but less than 10% want to implement anything. And there are several reasons. And I think unless people really see live examples that what has been done, and there needs to be a good enough data from prior to implementation and after implementation. So once those kind of visible examples are there, I think that hesitation will still continue, though everyone wants to at least talk about digitalization.
Very true. And I think this is, we can complement your research, but also with work that we've also seen through some of the partnerships we've had, or the partnership rather we've had with the World Economic Forum, where we've seen that digital transformations in industrial settings, right? Now let's say expand from the refining context to more broadly the big industrial sectors, let's say like metals, mining, EPNG, etc., consumer packaged goods manufacturers. They have struggled to scale digital and analytics, primarily because, as you said, there are no lighthouses, right? Toyota had this concept of lean, and everyone used to go and visit Toyota to understand how to apply lean manufacturing. You do need these lighthouses, especially in the region, to actually showcase how can you extract value, the full value. And that's, I think to education, like these sessions is one step along the journey.
Yeah, there is a question. What would be a reasonable ratio CapEx EDCI for a refinery digitalization plan based on your experience?
Yeah,
Mr. Rafai.
Maybe Vinay, I would frame it as more of a what is the return on investment kind of.
Depending on the context of your refinery and what is the strategic roadmap that you have, we've seen, very attractive return on investments for these type of programs, especially if you look at the production domain itself, right? If you're able to drive at scale some of these AI-enabled transformations, you're able to capture the value of the full program within the first 6 months or so, each year, and then obviously, this is like a gift that keeps on giving. Once you've actually built that capability. So in that sense, we've seen very attractive return on investments, especially given that, as Pawan is mentioning, a lot of these solutions are open source. If you wanted to go down that path, so and therefore the capex required is not as much. You're trying to sweat your own existing assets and drive the business transformation. So the ROI is quite attractive if you look at that spend and that sphere in terms of where the value is.
And just to link to that, even the second question that came in, thanks Ahmad, for which one would you prioritize, right? So can a refinery digitize part of it, or the whole transformation needs to happen? And I will link also this to Rafael, your question on ROI as well. So typically, you need, whenever you think about digitizing the refinery, you think about end-to-end digital transformation. Yeah? And that includes different domains: production, maintenance, procurement, supply chain, etc. But also technology and organization part, yeah, that we discussed. And to start the whole journey, typically what we have seen, again, there are different models, but the most typical one we have seen, you kind of start with a pilot, yeah, in the domain which will have highest impact and easy also to implement. Yeah, so very high return on investment, in year payback of 3 to 4 months. It should be as short as that, so that you can go to the board and show the impact and generate momentum within the organization. Yeah, and in parallel, design the whole transformation, how it would look for the refinery, and then you pick up module by module and start implementing. Yeah, and some of them go, and these use cases go in parallel, yeah? Along with the application and use cases, also the technology and the automation.
Let me express my sincere appreciation to the McKinsey Company, and especially to you four experts for sparing your time and effort and sharing your experience and insights with our subject matter experts and our audience. And I hope you have enjoyed it as much as we enjoyed interacting with you.
Thank you, Raj, from our side as well, especially to you and Sama, who made this happen. So thank you, Sama from McKinsey, and Raj, you from GDA, and thank you everyone for joining 2.5 hours more with us. Happy to take any further question you can direct via Raj. Happy to answer those, or you can also write to us directly.
That's true.
Thank you, everyone. Cheers. Bye.
Thank you, Vinay. Thank you, Thomas. Thank you, Pawan, and thank you, Vikas. And let me now close this session by saying that this is not the end of the journey. This is just the beginning. And there will be many more webinars where we will talk about this subject from various angles. As Gurminder said, digitalization is not the only way to improve our margin and make the profit. And we will be examining all other aspects as we go along. Now, for those who have not been able to raise your question, and if you have a question, please do write to us at info@gda.org.bh, and we'll be happy to get you the answer through the experts we had today. And we also urge you to go back to our website and view our other 15 episodes with various leaders of the industry discussing various topics of interest. And we hope you will definitely benefit from all of them. And we also hope to see you in the next webinar, which we'll be holding in a month's time. And until then, we wish you all the best. Stay safe, stay healthy. As they say, stay positive, but test negative. God bless.